Well, we are back, and this one is the last section in Unit 2. It's section 2.9, and all we are talking about is the math class. Well, I introduced this one a lot earlier, so we've seen it. We've worked at it in Introduction to Computer Science as well, and we pretty much know this one. So I'm just going to go through this one really quickly, stating a couple of the methods. There are a lot of methods in the math class, a lot. But we are going to just look at a few that are used frequently. So the first is math dot square root, and we've seen that one before. The answer is 2. Math tends to send back doubles though, so the answer would be 2.0. Here it's 3 squared, which is 9.0. Absolute value of -2 is 2. And the min and max are two important math methods. These are all static calls. So, and if you're wondering at this point what a static call is, then you weren't paying attention. But I'll say it again. A static call is the name of the class dot the method name. It must be declared as a static method to be called statically. Okay. So we don't say math m equals new math and then say m dot square root. That would be a non-static call. So with max would return 5, this would return 2, and so on. What if I wanted to find the maximum of 3 values? Let's say the numbers were 12, 20, and 9. How would we do that? Well, we have to do a nested call. I'll show you that. A nested call. So we got to do math dot max. Okay, and inside I'm going to say math dot max again. I'm going to put in 12 and 20 comma 9. See how I did that there? I'm going to close off the print. So you could see I'm nesting. So since I have 3, there is no math dot max for 3 values. Okay, you can't say, let me just put this down here. We can't do this. Math dot max 12, 20, 9. That does not exist. Okay, you can't just decide to make up stuff. Math.max and math.min takes only 2 values, but yet we could use it to find the maximum of many values. Okay, so we just got to nest the calls. And by nesting the calls, I mean make a call of math.max inside math.max. Same for min. Now, the last piece we want to touch on is random numbers, and this one is a topic we did in the Introduction to Computer Science, and the way we used to do it is by using the random number generator object. Okay, we used to make the instance, and we used to say either gen or rand. Those were the two we would use, and gen for generator and rand for random. And random gen equals new random. If you do this, you're going to get a line under unless you import it, so you may have to go ahead and import the random. And then you say gen.nextInt, and 26 plus 5, let's see if we can remember that. That's from 5 to 30, because 26, okay, 26 does not mean anything to do with 26, the number. It means 26 integers are possible starting from 0, so that would mean 0 to 25. So since I could generate 0 to 25, which gives me 26 numbers, I can add 5 to both the 0 and the 25 and bump that up to 5 to 30. And that's the Introduction to Computer Science way of doing random. The other way to do random is using math. Math.random is another way to get a random. That, though, prints all doubles on this half closed interval. Again, we're coming against this. It starts with 0 included, 1 excluded, so you can't generate a 1. Now, here's the thing. This math.random generates percentages, okay? Because since it's generating numbers between 0 and 1, 0 included, it could generate like 0.5, 0.632, 0.879. So it's going to generate a percentage, okay? So it can't generate 100%. That would be 1. It could generate 0%. So what if I wanted to do the same thing here as 5 to 30? Now, I'm going to go to 30, 30 excluded. All you got to do is multiply the math.random by 30 and add on 5. Okay. So right there, we could generate that type of thing. And this would generate numbers between 5 and 35 included and 30 not included. So these are things that the math class has that we can use. If you don't want to use this random, you could always just use this one. That's fine as well. And yes, this has a next double as well. So this brings us to the end of Unit 2. 2.9, the math class, is one that we're going to be using quite often. So this is not the last time seeing this one. And this was a long section, 9 different parts to this unit. And what you want to do here is make sure when you come across these things, you don't just stop at this. Okay, you go and you check out the math class. You can look it up in the API and see what else methods are in there. Broaden your knowledge. Don't just limit yourself to what you see here. There's a lot more in the math class, a lot more to pay attention to and to find out. Just be a little curious. And one way you could do it is just simply type math. Because math is completely static dot, and just look through the list, like E 2.718, Euler's constant, not Euler. Pi, if you want to find out, you want to do something with calculation that includes the pi, you could use math.pi. Here's the absolute values. It's overloaded. See, absolute value of many things. A cosine, which is arc cosine, which is the same as cosine inverse. And then you could add two numbers, and so on. And you have sines and tan. Even hyperbolics are in here. Cosh, hyperbolic cosines. And we have all these. Hyperbolics are a very high level topic for engineers, but then we have the get exponents and hypotenuse. If we have x, see that, the square root of x squared plus y squared, the hypotenuse thing, we could actually use that. And a bunch of things in here. So logs, okay, if you want to find out the log of something. So a bunch in here, and just take a look. Don't just limit yourself to what you see here. And again, we're at the end of Unit 2. This was Unit 2.9, and that's a wrap.